Today we will discuss particle dynamics, and in particle dynamics we will discuss constraint relations. Now the first thing which comes to our mind is, what are constraint relations? In constraint relations we take the length of the string. The string is ideal, remember, it is light and inextensible. So we take the length of the string as a constant, and using this length we try to establish a relation between the displacements of the moving objects. So why we are calling it as constraint relations? Because we are taking the length of the string as constant, which is a constraint. Let's say in this question, this is an ideal string. One end of the string is fixed to the wall. This is an ideal pulley, that is, pulley is massless and frictionless, smooth. The other end of the string is tied to a block which is kept on a frictionless surface. The pulley is pulled with a force F. We have to find the relation between acceleration of block and pulley and also their magnitudes. So let's write down the force equations first. Writing force equation for the pulley, first we draw the free body diagram of it. This is the force F acting on it in the forward direction. Tension in the string is T. So these are the tensions on either side of the strings. Mass of pulley is taken as 0 and acceleration of pulley is taken as, say, AP. So writing force equation for the pulley, we have F minus 2T is equal to mass of pulley is 0 multiplied by acceleration of pulley, which comes out to be 0. So this implies that tension T in the string is F by 2. Now we have, if we draw the free body diagram of block, the force acting along horizontal direction is T, and let's say the acceleration of block is AB in the forward direction. So we have tension T, this is the force equation of the block, is equal to mass of the block M into acceleration of the block AB. This implies AB is equal to T by M, or it is F by 2M. Okay. Now the challenge lies to find how to find the acceleration of pulley, that is, how to find AP. For this we use constraint relations, because this is a compound pulley system. Why compound pulley system? Because the pulley is movable. Okay. So how to write the equations for constraint relation? See, this is the string and this is the fixed point of the pulley block system and string, right? This is the fixed point. So once we have identified this fixed point, what we should do is draw a reference line from here, and from this reference line assign length to all the moving objects. So this length is, say, XP, and this length is, say, XB. Now it says write the length of all the strings in terms of these assigned lengths. So we have only one string. This was the string. Let's take its length as L. So this L is equal to XP plus XP minus XB, because the length of the string is XP plus XP minus XB. This length is XP minus XB. So we have, if we differentiate it, we have 0 is equal to, because length is a constant, the string is light and inextensible, it will be twice velocity of pulley P minus velocity of block B, because we are writing dxp by dt as Vp and similarly dxb by dt as Vb. Now again, when we differentiate it with respect to time, we get it is twice of AP minus AB is equal to 0. or we get AP is equal to AB by 2, which is equal to F upon 4m. So just now we saw that by using constraint relations, we can find the acceleration of two bodies which are connected by string. Remember this line that constraint relation is required in a compound pulley system if pulley block system is observed. This is most important because as soon as you see a compound pulley system, it should click to your mind that you have to use constraint relation. Now let's take one more example. We want to find simply the relation between the acceleration of A and B. Now in this entire system, this object is at rest. So draw a reference line from this point, that is the reference line in this reference point in this case. Assign lengths to all the moving objects. So we are assigning length to block A, we are writing it as XA, and we are assigning length to block B and we are writing it as XB. Now we are taking the pulleys as an integral part of blocks A and B and their dimensions are negligible as compared to the length of the strings. So now let's try to write down the length of this string. Please follow it. This is the string in terms of the movable objects A and B. Okay. So we have the length L is equal to XA, XA, XA and XA. It is 4XA plus it is XB, XB and XB, 3XB. Now when we differentiate it with respect to time, we get this as 0. This is equal to, see the length of A is decreasing with respect to the reference point, right? So we write it as -4 dxa by dt plus 3 dxb by dt, or this is equal to 0 is equal to -4 va plus 3 vb. Now once again if we differentiate it, we get it as 3ab minus 4aa is equal to 0, or acceleration of B is equal to 4 by 3 aa. So this is what we have, that is acceleration of B is equal to 4 by 3 times acceleration of A. So this is how we can use constraint relations to find the relation between the acceleration of moving objects using the length of the string, right? So remember it, this was XB, this was XA, the accelerations of blocks are AA and AB. Okay.